Hello again, Math 2 peeps. Hope everybody's doing well out there. Everyone's safe and healthy. Today you'll see here, I really attached two things to your Skyward message. One is called a review, one is called review number 2 as a homework. This is really going to get you through the next couple of days, so for today and tomorrow. Today we'll just go through a review together. Thursday I'll attach another review just for you to do on your own, and then plan on a quiz on this material next Tuesday. Those looking to raise your grade on the quiz category, that'll be your next opportunity, okay? If you kind of look through this here, we'll go through this guy together, and then that second review that I'm going to leave you either today or tomorrow, or today or Thursday. I'll think about what I want to do with that. Will be pretty much the same stuff. Those two things together should have you in pretty decent shape to take the quiz next Tuesday. First 12 is really just some definitions, making sure that we have all these things straight. There's a lot of new definitions, a lot of new notations and everything in here. So hopefully we are getting this. If not, you'll have a couple of sheets here to hopefully figure that stuff out. It's just a little matching 1 through 12 with whatever I gave you here, and then whatever that's called with our list above, using the circle as a reference. So number 1, if you look at GB, you have a line on top of it. Line is because you have arrows at the end. So if we look at line GB, so here is line GB. Notice how it hits our curve in 2 different places, but it doesn't stop there. It continues on to the left. We have arrows here saying we continue on to the right. So when we intersect the circle twice and we pass through the circle twice, that is called a secant line. So we have that one done. Line DP, that's another line because we have 2 arrows at the top. So if we find line DP, similar in the sense that this is a line that goes on forever, but we're only touching the circle one time. When we do that, that's called our tangent line. So the difference between a secant line is we cross twice. Tangent line, you're just going to cross the once. All right, we're done with that. Number 3, segments. Notice how there's looks like a line on top, but there are no arrows at the end of that. So this would be read as segment FM. So if we find F, we find M, connect those. What that is the radius of our circle. So we can get rid of that. FG, when we see that little symbol at the top, kind of a curve, that's our arc. So this is arc FG. So if we look at the arc drawn from F to G, when we only use 2 letters versus 3 letters, this is a minor arc. It means we are less than half of our circle. So if we look at this arc, that's definitely half or less than halfway around that circle. So that's why it's called a minor arc. I'm going to actually have you jump to number 6 next. This is an arc that has 3 letters. If we look at that, we're going to start at H, we're going to go to B, and then we're going to go to G. So if I drew in this arc around the circle, this is more than 1/2. So this is still an arc, but we would call this a major arc. That's the difference between a minor and a major. So keep that straight. 2 letters are used for a minor arc. 3 letters are used for a major arc. Let's cross those out. Back to number 5. If we wanted segment HE, so if we find segment HE from here to here, it also hits the circle in 2 different spots, but since it starts and stops at those 2 points, that is a chord. As opposed to the secant, the first one, we hit the curve in 2 different points here and here, but since our line continued on, it's a secant. If we start and stop on those 2 points, that's going to be a chord. 7, this is how we label a circle. So this is circle M. A circle is always named by its radius or its center, and in this case, M is our center. So we're done with that one. And let's get rid of minor arc. We've done that one. Angle, this is our angle symbol, KHE. So if we then find K, find H, and then find E, here's K. We're going to come over here to H. We're going to go over here to E. So here's the angle we are creating. Notice where your vertex is at. It is on the circle. And if it is on the circle, that is what we called an inscribed angle. Get rid of that one. D is you don't have an angle in front of it, you don't have a circle in front of it, you don't have an arc on top, you don't have a line or a line segment on top of it. What that means is that's just a point. So if we come over here to D, that is a point. And in this case, since our tangent line, that's where we're hitting the circle, that is what we would call our point of tangency. Segment KH, so if we were to find K and H, here's K, here is H. If we connect those, notice how it goes right through the center of our circle as well, from one side to the other. So this is technically a chord, but it's a little bit more specific than a chord. What this is our diameter. A chord that runs through the center of your circle is your diameter. So we're done with that. Done with point of tangency. Chord we're done with. So two left. Angle F, M, H. So if we found F, M, and H. So here's F. F to M to H. So if we go from here to here, we have the angle symbol in front, so we know we're talking about this angle. The center of your circle is your angle, so that is what we call our central angle. And then last but not least, arc, H-E-K. So here is H, here is E, here is K. Notice how that is the arc that's created by the diameter that we just talked about. So here's your diameter. The arc that is created by your diameter is always going to create a semicircle. So that would have to be here. So know those definitions pretty well. When we do take that little quiz next week, there'll certainly be some of these types of questions, and you'll want to know what those are. Each of those have their own little properties to them. A couple of problems, we'll just cover those. So if we were to find, this is now read as the measure of angle KCH. So here's K, here is C, here is H. So we want to know the degree measure of that angle here. That is a central angle, and the degree measure of a central angle is always the same as the measure of the arc that's created by that angle. So since this angle is the arc is 168, this angle is also 168 degrees. So for central angle, it's always the same as the arc. Measure of angle arc BKH. So here's B, here's K, here is H. So if we wanted the degree measure of this arc here, then it's the sum of 50. That got us from B to K. And then we want to continue from K to 50. So we would just do the 168 plus 50. And then that would be 218 degrees. The measure of angle BDH. So here's B, here is D, here is H. So what we are looking for is this angle right here. This is an inscribed angle. The degree measure of an inscribed angle, look at the arc that we are creating here with that angle. That degree measure is always half of the intercepted arc. So 50, 168, we've already done that over here, it's 218. We would want 1/2 of 218. So that should be 109 degrees. Last one, the measure of arc BD. So what we're looking for is this here. Here is arc BD. So what we would want to understand is all the way around a circle. We know all the way around a circle is 360 degrees. We know this is 50, so we can subtract away 50. Let's do this over here. We already have 168, so we want to subtract that away. We also have 42, subtract that away. All we are left with then, let me get rid of the yellow maybe, it won't let me. All we have left then is the purple. That would have to be 360 minus all those other degree measures. We would do 360 minus all of those. We would have 100 degrees left over. That would have to be this arc measure. So now if I took 100, 50, 168, 42, that should add up to be the full 360 degrees that we know go around the circle. Last two, similar. We would know that this 290 would have been represented here. First thing I'm asking you is, what's the measure of arc SJ? So what's the measure of this arc? So of the 360 degrees, that big one ate up 290 degrees worth of the 360. So what would have been left was 70 degrees. So the measure of arc SJ had to be 70 degrees. Then find the measure of angle SVJ. So here is S, here is V, here is J. We want this angle. It's an angle formed at the center of our circle, so it's a central angle. And this angle is the same as your arc. So this would also be 70 degrees. Angle VJH is kind of weird to look at. It is the angle, let me try to do this in purple. It's this angle from here to here. All right. No, correction. Let me read that again. Let's get rid of this. We want to go, let me just get rid of all of this so we can see this a little better. And then we knew this was 70. So that makes up our 360. So V here, we're going to go to J here, S here. So this is an inscribed angle. This angle that we want is called inscribed. It should be 1/2 of the intercepted arc. So what we would want to understand is this here to J is going through our radius. So if we continued on, if we know we're going through our radius, what that then creates is a 180 degree angle overall. So that would mean if I were to do all of this red, this has to be 180, but we already have 70 accounted for, so this would have to be 110. And by 110, I mean, let's do this as 70, so we'll turn this into black. The whole thing is a 180 because this is your diameter here. So 110 in red plus the 70 in black, that makes up our semicircle, which has a degree measure of 180 degrees, so it would have to be less than half. Inscribed angles have a degree measure that is 1/2 of the arc that it is creating. So this would be the 110 is the arc that's formed by that angle. We want 1/2 of that, which would be 55 degrees. So the first thing you're asked is to find the measure of arc VGR. So here's V, here's G, here's R. Notice how when we draw that arc in, it's exactly 1/2 of your circle, because if you look at our rate or our diameter here, that's where that arc is created. So we would know that that is 1/2 of our circle. We know that's got to have a degree measure of 180 degrees. If we wanted the measure of angle X, so if we look at X here, this is a property. If we have an inscribed angle, which this is, and if we look here, the two endpoints of that inscribed angle form your diameter, which it does. It's from V to R is your diameter. What that guarantees us or tells us, this is a 90 degree angle. It's also just understanding, if we look at these two from this point around to this point, an inscribed angle is always 1/2 of the arc that it intercepted. So if we know this is a 180 degree arc, which we did already from the first problem, the inscribed angle has to be 1/2 of that. So cut that in half, it should get your 90 degrees. All right, let me get rid of this. Don't need any of that. Let's label this 90 degrees. All right, VR, If we then now know that this is a 90-degree angle, notice how we have a triangle in here. So let me trace this in red. So notice how we have this triangle. Notice how we have this 90-degree angle right here. So the way we can find sides in a 90-degree angle is our Pythagorean theorem, as long as it's a 90-degree angle, which we know. So what we are looking for is our hypotenuse here. So we know this length is 10, so we would do 10 squared. We know this length is 24, so 24 squared. And then the side that we are looking for is our hypotenuse, so that is our c squared. Throw those into the calculator. This one pretty simple. 100, 24 squared. I think I know what that is, but let's not risk it. Yeah, 576 equals c squared. Together, 676 equals c squared. We would then know to get rid of this little squared term. That's when we use our square root. So we would then go ahead and take the square root of both sides, and we would get c equals. Doesn't look promising. Throw that into your calculator. However, it actually is a nice number of 26. So the length of VR would be 26. Next one, the measure of angle VEW. Where's that at? So let me create a little clearer picture here. So let's put the 90 back. So the measure of arc VEW. This is a central angle. Look at the arc that this is creating. It creates this arc here. And what we know about a central angle is this angle will have the same degree measure as its arc. So what would be nice to know is whatever the degree of this arc is would have to be the same degree as our angle. So the way you would have to do this is understand, we use the big fat yellow one here. That has to be 180 degrees. That's our semicircle. And what we know is that since this central angle is 48, this arc is 48. The entire yellow arc is 180. We would subtract 180 by this 48, and what we would have left over for up here would be 132 degrees. So now if you add the 132, add the 48, that gives us that full length, which has to be 180. And now that we know that this arc here is 132, this central angle has to have the same exact degree measure. Okay. Last one, I wouldn't do that to you, not at this point, not with us not being in school. It's a nice little review of something old with the SOHCAHTOA. But in terms of our quiz, just know the basics, know the definitions on those first 12 problems, and then be able to kind of play around a little bit and know all the properties of these. I wouldn't necessarily then throw in a trick question like this last problem would have been. We were in school maybe, but not when we're doing this alone. So hopefully that makes some sense. If you have any questions, again, reach out. You will have a second one of these to do. It's just a practice that I would then ask you to submit. So don't submit this, but that second quiz review that you're going to be getting, go ahead and submit that to me. That'll be really your only work assignment for this week. And then next Tuesday, you'll have a quiz. Hope everyone is well. Have a good day.